Well, welcome back once again to me working on that Philco model 39 or 3892. Yeah, this is one where I was telling you in my last video about how someone had cut off. I don't know if we can zoom in close enough to see it, but someone had cut off this the positive side of this 8 microfarad section of this electrolytic filter capacitor, this can. They cut it off because it initially went to that wire there, and they had soldered it there and then taken the negative side and hooked it up in place of it. I'm pretty sure that initially this guy was initially connected right there, because this wire here is the only one that is not cloth and it's not factory, and these are really nasty looking solder connections. So because this wire is kind of degraded, falling apart, I'm assuming that this radio must have worked for some period of time. Don't know how long or why somebody would do something like that. But if you do, well, here's the results of the damage that something like that can cause. Now, this is my favorite radio. I wish I had the cabinet to show you. I'll get it back from the paint store someday. But I spend more time playing with this radio. I just love using my test equipment and moving it around on these and playing with the alignment on it, because it's got a whole bunch of controls. It's got 3 IF cans. It's got 2 audio state. It's got two IF stages in it, plus the initial detector stage. It's a multi-band radio. It also has a short wave band. So as a consequence, it's got a setting for the the tuner here, then one there, then this one's for the the short wave, and this one that's got 2 down here. Then there's one underneath. So I just love just trying to tweak and peak this guy. It's a lot of fun for me. But the cool part about it is it works great. This is its speaker. I don't know, I'm learning. This is still a learning process for me. I'm just an amateur learning how these things work. This is the voice coil part of an old style electrodynamic speaker. This is the audio output transformer. This one has 4 wires, but when I got into examining this plug here, I found out that this guy is 2 of these pins are bridged inside the connector. And I know you can't see down in that hole, but I drew a little graphic of it. If you look here, 2 of these, oops, where'd it go? 2 of these guys, 2 of these pins are close together, 2 are further away. So I drew a graphic of it. It has a little piece of wire bridge in it, and this one goes out to the coil. Then it has 2 wires that go up to a common connector, which is these 2 wires are connected, so it makes for a common connector. One wire will go to the audio output transformer. The other one will go to the voice coil. And then the other 2 wires, one goes to the transformer, one goes to the coil itself. So, and that's how they did it. The reason I wanted to investigate that is because this is a speaker out of the Philco. And if you notice, it has 3 wires. Effectively, even though there's 4 here, it's just doubling up one of the wires. So if I go and take my really handy-dandy little... Actually, I love this meter. I've had this thing just about my entire life. And I connect it up to the one that says T2 there. It has the common. Well, let me see if I can do this with one hand. I gotta hold it like that with this finger, then connect that onto here. Okay. Oh, lost it. Shucks. Try it again. Okay, so I got my thing clipped onto the one with the 2 wires going to it. That's the common one. Then I hook it to, this one goes to the transformer, and I get a reading of 448 ohms, half a kilo ohm. The other one, which are looped together, says it's 2.3 kilo ohms. Notice how the readings on both sides of this thing are just dead rock solid. This is why something like that, you don't start just cutting wires off and sticking them on other locations, because it kind of makes it work and it didn't cost anything. On this guy, the two common wires, it's got one, this terminal here. One, it has a little wire on the other side of this terminal that goes down to this. Then it has this one loops into the coil. So this is the common one between the two. Okay. Now this wire, I'm going to hook it up to the audio output transformer. And you'll notice it is just jumping all over the place. And it's in the mega ohm range. That's effectively, although it's getting some sort of capacitance connection, that's effectively open. Now we're going to hook it up to the voice coil. And it is wide open. Yeah, and I'm also kind of doing this for a friend. See how this is just a terminal. It's not connected to anything on the bottom. And it has a black wire going in there. Here's the other wire. So these two wires, it's wide open. As a consequence, even though I've got this thing recapped, and I'm monkeying around with this, I'm going to fix this, but it operated, clearly it must have operated for years before it fried that. I don't know exactly why it fried. Perhaps one of these bypass capacitors, or may have become too much for the speaker to handle, just sent too much current to it and cooked it. Because these were conducting a lot more electricity than what brand new ones would. Anyway, I had this thing up, rolling and running, and I have a signal tracer, and I chased out the entire circuit, and it tunes the station, and it's nice and loud all through the entire band until it gets to this point. When I go and hook on my signal tracer in audio format, I get nothing here. When I put my signal tracer on, so that tells me that at least this transformer was bad. And then when I went to go check the coil, it was bad too. It's a real shame too. Look at the condition of this speaker. It's nearly perfect. I'm going to contact this is why you join a radio club. I'm going to contact my friend at the radio club who has extra stuff like this lying around. See if he can find me another speaker, because it would be pretty cool to get that radio up and rolling. Anyway, you guys, thanks for watching, and I'll have more for you next time. Bye.